So before what we did was we did those broken line graphs, right? Which is where you have your plots here, you label your stuff, you set all the dots, and then you just kind of like connect them, right? That's a broken line graph. Now we're doing something called a bar graph, and you've definitely seen these before. A bar graph is going to look something like this. We saw a couple of these yesterday when we looked at those like misleading graphs, but like this is going to be like what a bar graph looks like. It's a whole bunch of different bars, like different things that kind of rise up that go all the way around it. This is what's called a vertical bar graph. So that's just like the difference between the two of them. We'll go more in depth with that, of course, but oops. So there's a couple things. Page 27. So if a broken line graph is used to compare different sets of data using multiple lines on the same graph, these bar graphs are used these are used to plot data using rectangular bars. We'll talk about what discrete data is in a second. So you can either have these be vertical or horizontal, and you can have spaces between them, or you don't have to have spaces between them. So these have a bunch of different advantages. There's a couple different ways of doing it, which we'll get into here. But so when we go into something called discrete data, this thing here, so this is data that this is the fancy way of saying it's data that has to be a whole number. Like if I was to say, what was the average number of like students we had today? There was 5 in the morning, 4 this afternoon. I don't have 4.5 students, right? I don't have 4 students and then just a torso, someone with no legs, right? So we have 4 students right now. And then in the morning, we would say we had 5 students, not an average of 4.5. So discrete data is like a whole number. So same thing. We have a couple key ideas here. We were pretty good at this yesterday, so I'm really happy about that. We're pretty good with setting the scale, labeling stuff. We want to give the graphs a title, and we looked into how graphs are interpreted differently depending on the scale that we use and the starting points and all that other stuff. But essentially, when we use, I shall come back to that stacked bar graph. So let's do a quick example here together, actually, of what a bar graph would look like. So in this one here, so in 2001, Canadian census listed the following populations of different cities, and they rounded it to the nearest thousands, to the nearest thousand. So in my graph here, I have 7 different cities, and I have their population in thousands. So Calgary would be 951,000. Vancouver would be 1,987,000 here, right? There's just the 3 zeros that aren't put there. So the reason you would use this in a bar graph here and not like a broken line one is, when we're looking at like a broken line graph, we're looking at stuff like the stock markets, right? We're trying to follow what happens to something over time. In this case, though, this is a bunch of different things, just at like a one-time snapshot. So that's not going to work. So what we actually do here, I'll scroll out a little bit. So I can see, first off, I have a total of 7 different cities here, right? We're going to do a vertical bar graph for this, which means we're going to actually do a bar. It's going to look something like this at the end of the day. It'll look something like this. This is about what it's going to look like, if that makes sense, if we can kind of picture it in our head. And each one of these bars is going to be a city. So this one right here, for example, might be Vancouver. So what we're going to do is we're going to give each of these bars, there's conveniently 7 spots. I wonder who did that, for 7 different cities. So we're actually going to put those in here along here. So this one over here, oh my gosh, like you'd put, I can't do it on this computer, but you put Vancouver here. I normally turn my page for this. And then you'd put like Calgary. The reason we like slant our writing is because you won't have enough space otherwise. So this is actually a little bit easier than the other one because you don't really need to set a scale down here. We just kind of need to put the bars there. Like that's it. We just need to label this column's Victoria, this column's Calgary, this column's Victoria. So it's actually a little bit easier in that regard. The only thing we need to pay attention to, so first off, this is our cities, label that. The only thing we need to pay attention to is going to be when we set our scale for this thing. So this is going to have, and same thing, this is going to be the exact same thing throughout all of it. So we'll need to count it once. There is 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's a total of 10 of these lines that go up. And I can see here my biggest population is Vancouver with just shy of 2 million. So if I take 2 million, divide that by 10, each line should be about 200,000 then, right? So why don't we do that? So we're going to put population in thousands here, just so we know. And then we're going to go up. Well, I'm going to go up by 200,000 every single line. By 500? So to do that, your graph would be a little scrunched together normally. Like it works. It works. It's just we could use the space a little bit better. There's no such thing as a perfect graph, right? It's one of those things that everyone can interpret differently. So they're saying, so in this case, it's 1,987,000 there. Yeah. So all I'm doing is each line it goes up, I'm just adding 200,000 people. Ooh, I didn't right. 1,400. I apologize. I can't really make it that much bigger just because I want to be able to fit the whole graph in here. 1,800, and then I have 2,000 here, which is technically 2 million. Okay, so once we've done that, I'll give you 20 seconds. Okay, so once you've done that, you should have a graph that kind of looks like this right now. So then you can probably guess what we need to do next. All we need to do is we need to, so Vancouver is 1,987 here, right? All I would need to do is figure out about where that is, and then just draw a horizontal line, draw a straight line. So this one's going to be something like this, right? I need a ruler? Right there, by upside down the Xbox. So just need to draw like kind of a straight line. And then what you actually do is, you see there's this little line here. You want to actually go all the way down it. So you actually want to go down this line here. So that way that it's set separate. And so you've drawn your horizontal line, you went all the way down, and then you just do your next city, which is Calgary, which is at 951,000 people. So you just do your best to guesstimate where that would be. Guesstimate's a word I use a lot in math. So same thing, draw your horizontal line, go all the way down. We have Victoria, that's about 300,000. So I put that there between the 2 and the 400. Edmonton, 938. So once you get to Edmonton, normally we've just gone straight down on the one side. That's because the graph's always gone down and down. Now we've actually gone back up. You want to actually go down on that line on both sides. Remember, you're trying to set this entire bar apart. So I'll wait till you get to about this point. Recorded. So does everyone have this point on their graph already? So if you do, one thing you've probably noticed is it's hard to see. Now, so what most graphs do is they actually fill this in all the way. Now this takes a lot of time. So you don't need to do that, but what you still want to make it stand out. So one thing a lot of people do is they might do something like this. They'll put a bunch of like diagonal lines in it. It just adds some filler to it. So it's a lot easier to spot. So I'd recommend you do something like that. Sometimes what they do is they try to like make the lines distinct. In this case, we don't need to do that. So you can do that horizontal line thing all the way throughout, and that would be fine. And this doesn't need to take long. They don't need to be straight, nice, neat lines. You can just kind of do like this, where you just freehand in it a little bit. That's fine. But all of a sudden, it's now a lot easier to look at this graph and compare it. Another thing a lot of people might do is they might make these lines here. Actually, see if I can bump that up a little bit. They might make these lines here a little bit more pronounced, a little bit easier to see. Because now it's a little bit easier to differentiate these two lines here, right? So nice bold lines going up and down, and then filling it in is a really good way to make sure your graph is easy to read. So my final product kind of looks something like this. Okay, here we go. So a bit easier to read now. So is our graph making sense then? We can read that fine? Okay, so that's how we draw just like a standard bar graph. So remember, this is called, you want to write this somewhere here. This is called a vertical. I'll use the text function. So this is called a vertical bar graph. Let's make that a bit bigger. The reason it's vertical, it's because the bars go up. They go up and down, vertical. And that's what that means. So if we keep moving on then. So now we're going to have something here. We have some more data here of the population of moose jaw between 1980 and 2005. Now this goes up in 5-year increments in this case. So one thing that's a little bit different here, if we go up to like back to question 1, this one here was just a whole bunch of different cities. We didn't need to think much about it. Cities go on the bottom, population goes on the top. They all shoot up in the air, right? This one we need to think a little bit about because our two different data points are either our year and population. And you're always going to have the number of people on this left side here, or on the thing that goes up and down rather, which means that our year would actually be down here in this case. So we're going to be doing a horizontal and a vertical bar graph with this. So we're going to start with the vertical one. We're going to do that one on the right here. So this one over here is going to be our vertical graph. And that's exactly what we just did. We've just changed some of these variables. So first off, I'm going to label each of these, right? I know my population is going to be on that y-axis for the vertical graph. Actually, put that on the right side. Put that on the right side. So my populations is going to be on the y-axis. That's the one that goes up and down. And my year is going to be on the x-axis. So I can see here that these are in like 5-year increments, right? Well, yeah, 5-year increments. So starts in 80, then goes 85, then 90, 95, 2000, 05, so on and so forth. So you see that a lot. Normally, if this was like this is a broken line one, you know, it looks something like this. You could technically plot it like that if you wanted, but this is also going to be used to compare that same set of data. So one thing we're actually going to do, instead of putting cities down here, we're going to put years down here instead. So I'm going to start with, 1980 here, for example. Then I go 85, 90, 95. No, population's on the y-axis here because we want to show how much the population goes up each time. Yeah, so we usually want to put time on the bottom and then so usually time on the bottom is a really good idea, but then this is comparing the number of people. So you want it to be, if you see a higher number of people, it's a larger group of people there. Oh, I see what you're saying. We will do horizontal later. Right now we're starting with vertical because that's what we know. Now you're going to notice there's a blank bar here, right? That's fine. You can leave that blank. We're using most of our graph. All we want to do is use most of the space we have. It's never going to be perfect. That's okay. So next thing as well, remember, these are the space in here. There's 10 lines that go up. So a really nice idea would be take your biggest number here. Right here is so I have 34.3 and divide that by 10. You'd get 3.43. Not a nice clean number, right? Why don't we go up by 4s or 5s? Those are close enough, but also nice, easier numbers to work with then, right? So some of you might prefer to go up by 5s. Some of you might prefer to go up by 4s in this case. You can pick whichever one you'd like there, actually. That's okay. I'm going to personally go up by 4s, but if it works better for you to go up by 5s, you can do that. Uh, 20. So I'm just going to pause my recording here. So once you've filled it out, it should kind of look something like this. Hopefully with a little bit neater lines. Has everyone finished their vertical graphs yet? Yeah. So there's something about this graph. There's a way we could have made it better. So when we look at this graph, we talked about making trends and stuff. I'll just zoom in a little bit just to. So we talk about graphs here. There's a couple ways you could have made it better, other than straight lines, which I don't have the power to do on this computer. So first off, it's kind of all cramped together here, right? When we look at the trend here, it's very hard to see what's going on. You probably can make it out it goes up a lot, then it goes down a little bit, then it goes down a little bit, then it goes down, then it just stays the same. But it's very hard to tell. You have to look really closely. If you have to look really closely to notice that all of the data is different, sometimes 2 points on a graph will be the same. Maybe there's a way we could have made the graph. So if we go up to our data here, what's one thing we noticed about the start of all of these numbers? Sorry? They all start in 30s, right? So couldn't we have done what we did last time where we broke the graph maybe, started with maybe 30, and then we did up here might be 31, up here might be 32, 33, 34. Maybe we could have done something like that. That would make these, I'll use a blue here as an example. That would make these all of a sudden, go from here to here to here. It makes those differences a little bit more obvious. Now it's also a little bit misleading in a way, but we could have done it that way. That would be fine in this case because it's helping us see the differences between the population. We almost need to look at the table to actually understand what's going on there, right? So that's, I'm not going to get you to redo the graph, but that's just something to keep in mind is that we can always like adjust how we possibly do the graph to improve it. Next thing we're going to do is we're going to do a red, a little bit thinner. We're going to do a horizontal graph here on the left. So the difference with a horizontal graph, I'm just going to put HOR, so I want to write it all. Different with a horizontal graph is that instead of the bars going up, they go to the side. So your graph's going to look something like this. Has anyone started that yet? Okay. So if you haven't started, if you've started it, keep going. But if you haven't started it, one thing you could maybe do is why don't we do a bit of a line break in population? Because now what's going to happen is horizontal. All we're doing is we're flipping these where the year is now on our y-axis. And the population is on our x-axis. So why don't we maybe do a little bit of that? Like, remember we have this little symbol here. That means we're kind of starting fresh. Why don't we start at the smallest thing here is like 32. Why don't we start at like, I don't know, 30 and then go up just by like one each time. 31, 32, 33, 34, and then 35. If you haven't done that yet, that's if you already started before doing that, that's fine. You can keep doing what you're doing. But this could be a nice way to at least enhance those differences a little bit better. So you put your years on the bottom here. We do that little squiggle to denote that, yep, it's changed a little bit. And then what we're going to do is we're going to put the years not on the lines, but right here. So now we'd put 1980. Oh, I can use this now, actually. So now we'd put 1980 not on the line, but between them, because this whole bar is going to be something that we fill in. So you start with 80 and you just go up to 85 and then 90, 95 to 2000. Oops. Now, another thing we could also do if we wanted, you don't need to do this, is you could also, we now have enough space in our graph. Remember, we're now only using half of the space, right? We could space it out where we have a space between every single one of them. So now 80 starts here, there's a blank, and then 85 might start. And then there's a blank, and then 90 could start. Again, if you've already started, that's okay. I'm just showing you there's a bunch of different ways of doing a graph. There's not necessarily a correct way. And then I'm just going to actually move the 0.5 up here. We can do that sometimes. Okay, so take a minute, fill out your graph, and we'll see what that looks like. Okay. So looking at our two graphs, which one do we kind of prefer? Yours is probably looking a little different than mine too, but like, but I mean, do we like the vertical or the horizontal more? Which one do we think does a better job of showing this data? The horizontal one? So how come you think the horizontal one? Is it because it's going left to right, or is it because we spaced it out? Probably spaced it out. The best graph here probably would have been a spaced out vertical one in this case. But sometimes it's okay to space them out a little bit more by splitting that first 30. We didn't need that first 30, right? And this shows the differences now between this. Like we look at this 95 to 2000, this is the difference here, right? This is the difference right here that I'm kind of like filling in. This is only 0.8 of 1,000 this is 800 people right here. But you see that change a little bit more. So it highlights that there was a little bit of a reduction, as long as we also pay attention to the fact that we're not trying to use this to mislead people. We're trying to use it to highlight the difference more. Usually the vertical is usually a better idea at showing population changes, but because we spaced it out, in this case, the horizontal one's probably a bit better. So you could put whatever you'd like here, because your graph might be different, and that's okay. But what do we see when we actually look at the trend of the data now? When you look at the trend, and if you remember, the trend is, when we looked at that yesterday, that's just what do we see happening over time to that data. So what trend are we noticing with the population of Moose Jaw over time? It's dropping, right? We don't know why. We could make guesses, but we know that the trend here is that the population is dropping. So the population is dropping. Done. So if we go to question D here, we're going to skip E. So you can cross that one out because we've kind of already done that in some sense. But for question D, we want to make a broken line graph of it. And that's the thing where all you do is you put your dots and then you space it out. If we remember, this goes up by 14. This is our x-axis. So it goes to the right by 14 and it goes up by 14 as well. This is our y-axis. So if we want to turn this into a broken line graph, we title it Moose Jaw Population Over Time. What do we think we'd put on the x-axis on the bottom here? The population or the year? For the broken line graph of it on question D. We use the year, right? You want to usually put time on your x-axis here. So we would just say that, hey, this is the year. The next thing we have to keep in mind is we only have, so first off, we have only 6 data points, but they're all spaced 5 years apart. What we could do if we wanted is we could put like this starts at 80, then 82, 84, 86. We don't need to do that though, because all we're doing is like we don't have the blanks to kind of fill in there. So instead, if we have 14 of these and we have 6 things, why don't we just move these 2 years apart? So let's see if I can use text here. So if we start at 1980 here, not on the first, not on like this very left line, but on this one, oh my gosh, on this one right here that my mouse is going over. We skip a line and then we go 82, skip a line, then we go 84, right? This is gonna make the most use of my graph. I just figured out that I have 14 dots, I have 6 years. Why don't I make them 2 years, 2 lines apart? Oh, no, sorry, not 82, 84, 86. That's gonna be 85 and then 90. So all of a sudden, we now have some nice spaced out years that uses space very well. And so if we have years on our x-axis, that means on our y-axis, oops, we're going to have population in thousands, right? So now the next challenge we need to do is we need to figure out what's going to go on that axis here. And so we can see that what we need to do here is we need to go at least up to about 35. There's 14 lines here. If you do that, wait for my calculator. Bear with me, it's a very slow computer. So what did I say? I said 35 divided by 14. So about 2.5. Why don't we go up by like, so we could go up by threes. Don't write anything down yet, but we could go up where like, you know, this is 3, this is 6, or you go up by 4s or 5s or whatever. You could go up like that, but we're going to end up with the exact same thing here, right? Where they're all kind of condensed in one little area. Did it? Oh, okay. I'll take a look at that in a second then. So why don't we break this graph? Put that little squiggle there. Why don't we start at 30 and then go up a little bit more instead? So why don't we start at 30? I've used one line here. Now I'm at 13 lines. I need to go up to 35. 35 minus 30, I'm at 5. I have 13 lines instead of 14s because I've started a little squiggle there. 5/13, 0.38. Why don't we go up by a half? So now I'm at 31 here. So 30, 30.5, 31, 31.5, 32. Sorry? Oh, yeah. Yeah, so now you can write that. Thank you, Austin. I always forget to tell people when they can start writing it again. So if I do this, I'm now using most of the space in my graph. And then it's just a matter of plotting those points in. Now, remember, this is not a bar graph now. This is a broken line graph. This is what we learned yesterday, where all we do is we go to the point. My population's Y, this is my X. So 1980 is 33.5. So you go to 1980, which is going to be this line right here. And I go to 33.5 and I just put that little dot in, right? And then that's it. Then you just go to that next data set then. And you keep going and going and going. So you have to flip back and forth a little bit. And so then once you've set all your data, I'll give you a little bit more time for this. Then all you do is you just connect the dots, right? Okay, so this is what our graph ends up looking like here. when we've split it up. Now, this graph, the reason we're not doing E is because technically we just did E up here. We did make this graph a little bit misleading because it looks like the population's declining significantly, right? It goes all the way from over here all the way to down here. Oh my gosh, what a drop. It's not actually that big of a drop, right? We've just zoomed in on just the very tips of it. So we already did make a misleading graph, but I just want to do it just kind of like get some practice with doing these little broken ones. I never really did much practice with that. We're almost done. So, yeah, let me think here, actually. Yeah, let's just read one. Let's just read it. We've made a lot of graphs. Let's just read a graph for once. On page 31, on question 3, so Roger's a real estate agent in Red Deer, Alberta. The graph below compares the average house prices of new single-family homes and then resale, which are not new single-family homes. So he's comparing new versus not new homes, essentially. And so one thing we can see here, if we look at this, what's different about this graph than the other ones we've done is that he's now comparing two sets of data over the same period of time, right? And so what he did was, so this thing right here, this is a different type of graph that we've not had to do before. But I just want to point out, you can do it this way as well. This is something that you can do. I'm just looking at my notes. What did I call those? Yes, okay. So this is what's called, let's look at my notes. So this is called a multiple bar graph because there's multiple bars in one little section here, right? So that's we call this a multiple bar graph. So we go straight to question A. What was the average price of a new single family home in 2005? So which one of these, Stephen, which one of these ones? The new family home in 2005. Yeah. So what's the average price of a new single family home in 2005? 230. Oh, so it tells you right above it. It tells you the number right above there. So 240, right? So there's two of them, and there's two different bars in 2005. So we have to look at this little thing up here at the right. It's called a legend. I can see that new homes are the grayer part of it. So that's this line right here that I'm kind of coloring in. So if I'm looking at the average price in 2005 of a new home, that's this gray line right here. So that's this one right here. So I know in this case, it's not going to be 240. It's going to be $240,000 because that's the scale that it's in. So the answer in this case is going to be $240,000. Yeah, just the price of it. No, no worries, no worries. So that's how we read these multiple graphs. When you get this, you need to look at a legend. At some point, you're going to have to make a legend as well. Now, one thing to note is for you guys, let me just erase everything here. For you guys, like this was done in two different colors, right? You're not always going to have two different colors. One thing you can do instead is, I'll make a new legend here. Remember those like striped lines we did? You could do that, and you could do something like this, where you put like dots. And all of a sudden, that would look, you've now differentiated how those are going to look. So if you don't have access to colors, and you don't want to shade the whole thing because that takes forever, you can instead just change how it's interpreted with the lines in there. So you can do one with like little dots, one with like little stars there. You can put anything you want there, but usually dots and slanted lines is a good way to distinguish that. Okay, so question B there. So between what years is there a drop in the price of resale single family homes? So if we're looking at resale homes, that's going to be the black bars there, right? So what year was there a drop? 2009, right? And that makes sense, right? There was the whole huge housing crisis that happened. So yeah, you bet. So in 2009, there was a drop in the price of resale homes. And so then we're looking at the general trend of the differences in prices. So when it says the differences in prices, the difference between what? Yeah, absolutely. The difference between these two things, right? So the gap between each of these each year. So what do we notice happens about that gap as time goes on? Well, they rise in 2008, but we're looking at specifically at like the distance between these two lines here, right? Well, just a few thousand. But generally speaking, what's the trend that we kind of see? You're right. So there was 2 years where it fell, but what happened every other year?
New homes cost more.
No, new homes started costing more and more. Before, at the very start of our data, they were the exact same price. And then, yeah, well, that is right. Isn't that the trend? It is the change, right? And what do we see changes over time? We see that gap starts to get bigger and bigger. There are two outliers here. Yeah, yeah. Trends, absolutely what's in style. So the general trend that happens here and these differences of prices is that new homes start to cost, I guess a better way of saying this would they'd be more expensive, but whatever. New homes start to cost more than resale homes, right? Why would I like? Hey, if it costs the same to make a new house versus buy an old one, why wouldn't I just make a new house? So people start to do that, and all of a sudden that the price starts to change a little bit. There's more demand for it. So new homes start to cost more than resale homes. An outlier, which means something outside of the trend we've seen, exists in 2006 and 2007, where old homes actually cost more money. Does it make sense? I mean, as to why that's the case, I'm not sure. Maybe all like the new homes were like too far out of the city, like no one wanted to drive an hour to get to their jobs for some reason. Okay. Cool. So we have an idea of multiple bar graphs. Now there's one final different type of bar graph though, where in this case, if we have two sets of data being shown beside each other, one thing we can also do is something called a stacked bar graph. I think that red might be too dark. I apologize. So we're going to use that same data, but we're going to do a stacked one. Now, what a stacked one's going to look like. So, let me erase that. So before, when we had a multiple bar graph, it looked something like this. Don't draw this in. It looked something like this, right? What a stacked one does is it takes one of those, takes all that data, and it just puts it on top instead. So a stacked one just takes all that data and instead moves it to be on top instead. And that's why it's called stacked, because they're stacked on top of each other. So let's take that data and let's do that. We're going to keep the exact same scale in here. We're going to keep the scale in where the price is the same and the year's the same. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 years here. I only have 7 of these things, so we're just gonna get rid of 2009. We're not gonna do 2009. Don't worry about 2009. So I'm gonna keep this the exact same. So I'm gonna start with 2002, then 2003, 04, 05, and so on. And we're just gonna ignore that 2009 exists. Just to keep our graph nice and neat right now. That's not the purpose of it. Okay, and then once you have that, then what you can do is you can set this price here to be the same. So we're gonna start average price in thousands of dollars. We're not gonna do a line break. We're just gonna do a standard bar graph. So average price, thousands of dollars. And I know it goes up by 10 lines because we figured that out already. And I know I need to go up to 400,000. So each one of these lines then is going to be worth 40,000, right? 400,000 divided by 10 lines. Each of these is worth 40,000. Okay. So once you have your axes all filled out here, we have our thousands of dollars on the left, our years on the right. All we need to do is take this data and fill it in. So now in this case, we're not putting both of these in. We're putting a stacked one, which means we're taking this shaded area here and we're moving that to be on top. So we're literally just going to stack it on top of it. So to do that, we then need to figure out two things. We need to figure out how high that total stack thing would be. We need to add those numbers up. So 172 plus 175. 347? You said 347?
Yeah.
So we're going to draw that line here. So 347 is about 340, halfway between. So a little bit up. Again, you're just doing your best guess. It doesn't need to be exact. That's okay. So that's the first thing I need. The total amount of those numbers. Does that make sense where I've gotten like this line from? So all I did was I added up the 172 and the 175. Sorry? Because each one of these lines here, so I know I need to go up to 400,000, right? Oh, that's a good, oh, yeah, that's a big mistake on my part, isn't it? So, so I see what you're saying, Steven. So if I'm adding these up, by the time I get to this is going to be almost like, this is going to be like 700 and something, right? My graph only goes up to 400. So you're right, Steven. I've made a big mistake there. I didn't even catch that. So just double all these numbers. I apologize for the neatness of that. Just double all these numbers. So instead of 400, it's 800. Instead of 360, it's 720. Good catch, Steven. I do apologize. And everyone makes mistakes. Okay, so I'll give you a minute, but eventually this is what it's going to look like. Everyone there? Made their changes. Again, good catch, Stephen. Okay, so now what we do, once you've gotten there, now you start adding these up. So 172 plus 175, you said that was what, Aiden? 374?
Yep.
So now we find about where 374 would be on here. And then put that in there. So what's that? That's 360. So can
147.
oh sorry?
1347.
Oh, 347. Okay. So 347 be about right here then.
Or did you say that real quick?
Oh, sorry.
The Y part?
This?
Yeah. Like, did you make it direct?
Oh, I did. Yeah. So it went up to 800 instead of 400. So all I did was I doubled all those numbers. So that's the first thing I need is the sum of these two numbers. You add them together. That's what it is. The next thing I need to do is I need to also go somewhere in this line and I need to split them up, right? So I'm doing a bar graph here, but I also need to find somewhere in this line to split it up to show this is that and that's the other one. So what I'm going to do is I'm just going to pick a number, 172. Okay. I'm going to say that the black things, the resale homes, I'm going to say the resale homes are going to be the thing on the bottom. And I'm just going to pick that number. So resale homes sold at $172,000 that year. That is a round right here. Cool. So now all I've done is I've stacked those two lines on top of each other. But when you look at this, you don't know what's what, right? So now you need to make a legend. We need to make a legend so that we know what our resale homes are and what our new homes are. So we can look at this graph and we can figure out, oh, the top one's this, the bottom one's this. So you can put whatever you'd like there. I'm going to use little slashes for resale. And then little dots for new. Okay, and so then all I need to do is I've already said the bottom is going to be my resale home. So I'm gonna label that by just doing that little slant in there, and then put in my dots in the other one. Yeah, because some of these houses are resale and some of these are new. I did. That's what this little line here is for, right? This splits the two of them, but I still need to know which one's which.
But that doesn't even make sense because that's the total together.
Yeah, so the line up here is total of them together, but so it's a way to stack two different sets of data, but I still want to distinguish which one's which. So this whole line here is all the data, but I still wanted to know that this one's new and this one's resale. And so then I just keep putting that information in for all of my values here. So your graph should end up, your stacked bar graph should end up looking something like this. Now, we definitely get a different interpretation from this graph versus this one over here. Let me just erase everything on there. So the two graphs, when we look at them, we see different things. When we look at this graph, what's happening to the prices of houses? A lot, right? That's the first thing you probably notice is, wow, that line goes up and up and up and up and up and up and so on. When you look at this one over here, you probably see that it's gone up a bit, but you might not notice how much it goes up by. But not only that, you get a much easier way at comparing the cost of two different houses. So even though it's the same set of data, this is a really good way of showing how much overall it just costs more now to buy houses. The other one does a really good job at showing the difference between a new and a resale home. So when we're asked this question here, what's less obvious on the stacked graph than on the double bar graph? The price of houses is it increasing dramatically, right? It's increasing a lot. It went from technically about half of this all the way up here. So we see that the price has just increased so much. We can see that here. It's not the first thing your eyes go to. When you look at this, the first thing your eyes go to is you're comparing these two. You're seeing there's two things to compare to. Whereas over here, you care more about the overall height of it. At least most people do. Maybe you didn't, but that's just like a common thing you do. So that is bar graphs. I know we just did a whole bunch of stuff, so I do apologize for all the graph making here that we had to do.
What's question B?
Oh, question B, the price of houses increased dramatically. So why don't we've been making graphs for an hour. Let's take a break. Let's take our break 10 minutes early. And then what we'll do is we'll go into some practice stuff here. For the sake of time, I might cut some questions out, so I'll think about that. But you guys can go on break for now.